Okay, here we go. So, binutils is our first package we need to install. First, let's go up to where we need to be, and that would be LFS sources. Okay, here's all of our sources inside of here, and let's extract our binutils directory, tarbz2. Now, the convention on building this is you want to extract the tarball. Okay, delete the extracted package. And there's also a build directory that you have to create also. Okay, so for every package that we extract, we want to delete afterwards. We want to delete the extracted package, which in this case is binutils. Okay, 224 without the tarbz. There's also going to be another folder we need to create called a binutils build folder. Okay, but you do not want to extract the tarball. I don't extract my I don't want. Sorry. You do not want to delete the tarball. I do not delete my tarballs until after my system is up and running, and then maybe even if I want some space, I'll delete my tarballs. Because we're going to need to do this a few times. As you can see up here, it says pass 1. Okay, binutils takes 3 passes to actually be 100%. But the reason why it's a layering process, so we need to create a little bit of functionality, install some other programs to it, then go back and add more functionality to this package and several other packages like this to get it up and going. It's not a one-time thing, it's actually a layering process. So with it being a layering process, you do not want to delete your source tree, or your source tarball, because if you do, you'll have to end up going back to the universe again. Don't do that. Okay, another thing people get confused on is after you extract your directory, after you extract your tarball, in this case is binutils, okay, you want to cd inside of it. Okay, from within inside of it, you want to make a directory for both, back up and out, and call it binutils build. Okay, now if you look at where we are here, you'll see this is the whole entire binutils package. But we need to cd back up into our binutils build directory that we just created. And if we list this out, you'll see it's empty. Since we're only building parts of the package, not the whole package itself, you do not want to really build inside of that extracted directory. And a matter of fact, LFS won't let you build inside of that. Okay, you gotta follow the rules. A lot of people get confused exactly where you are when you're doing all this. I used to be confused, and I wasn't even inside the sources directory anymore. I was inside of root and all kind of stuff, and it was mayhem. But this is where you exactly are. If you say list grep for binutils, you'll see here that we're actually at the same level as all of our sources. This is our source tarball. These are our patches. This is our source tarball, which got extracted into this the binutils directory here. And we, like I said, we jumped inside of the binutils directory, and from inside of there we built our build directory, which was actually on the same level as our sources directory here. Okay, now we just jump back up inside of the binutils build directory. So we're not in some magical, mystical place. We are still right here. Let's go into our binutils build directory. Any sources, any configuration files that we build from now on will be loaded into this binutils build directory, which will be deleted along with our extracted directory that we took from our tarball. Okay. And the reason why we're doing this is it's away from everything else, and there can be no I don't want to say collisions, but there can't be any problems since we're only installing parts of the package, but not the whole package. So when we're in here, you're going to say binutils 224 configure. Use your tab as much as possible. This will save you from typing, and typing is leading cause of errors, misspellings, whatever. And if you say U tab, it will autocomplete the rest of the configure script. Saves you. Prefix equals tools. Okay, space and a new line jumps you down to the next line. And then we'll say with sysroot equals $LFS space and new line will jump you down to the next line with lib path equals tools. Actually, see, if I hit L tab, it'll automatically complete the rest of that. LI, that's not gonna work. If you see this flash, this is me trying to tab switch and it's not working. Okay, new line, and you can say target is equal to $LFS underscore target. Now, you don't necessarily have to throw new lines all the time. I do because it shows in the book, but in the older LFS version, the documentation used to be like this, and actually, it's easier for them to throw in new lines. NLS and disable W error. Okay, you can just string everything from left to right instead of vertical like that. That may save you some time with switching windows, and that's how I like to do it. Now we want to run make. Okay, the configure script is ran. We're running make now, and one thing I did not go over was SBUs. SBUs stand for System Build Units. Okay, and the way you're supposed to calculate System Build Units is from the time you extract a tarball to the time that you delete the extracted packages. Okay, or the time you extract a tarball to the time you're done with that particular package at that particular time. I think that's how they calculate SBUs. Now, if you say if a package costs you, for instance, this here is 1 SBU. If 1 SBU to you is 10 minutes, you can calculate and say that, say, 35 SBUs will be 350 minutes for you. Now, System Build Units is a good way to track and see exactly how you're doing. Your computer may fail, stop, things may happen, and it's a good idea to know when your package is scheduled to be done. For instance, if you have something like a 2 SBU and you've calculated and know that 2 SBUs to you is 20 minutes and your computer hangs all day, then you could have a serious problem. Okay, and it also lets you do other things. This is going to be a very long process. Talking about maybe a 15-18 hour build with a compact Celeron 2 gigs of RAM. Okay, so you may be in for a long time. It's a good idea to keep track of approximately how your ratio is between build units and real time to see when you can, you can kind of plan your day around it. Go get some soup, something to eat, pack cigarettes or something on the long hauls, and just do that. Okay, so that's that. Now this is going to take a few minutes to build. And another thing I want to say, when I come back, we're going to talk about this here. This is say if building on an x84, create a symlink to ensure the sanity of the tool chain. So since it says if, and if you're not building on a 64 bit, if you're building for a 32, I would assume you can skip over this, but I'm not sure. Refer to your documentation about that. LFS 7.6 can be built on a 32-bit machine, and in that case you may not have to do this. And actually this case statement itself would kind of void that. It says here, case, you name texture in, if it's x86-64, make a directory toolslib, link that lib directory toolslib64. Okay, and close case statement. So even if you run this as a 32-bit user, your machine architecture is not going to come back as a 64-bit architecture, and this case statement will fail for you. Okay, not fail as far as cause you problems, but this case statement will do nothing to you. Okay, so now that's out of the way. I am on an x86-64, so I'm going to say case $, encapsulate uname machine architecture in x86 underscore 64. Make a directory, Bose, tools, lib, and link, symbolic for Bose, lib, to tools, lib, 64. Okay. Looks good to me. Close the case with the exact case backwards. Okay. And make install. Okie dokie. BinUtils Pass 1 is done. You should have got no errors. Your output should look something similar to this. And if you get errors, you know you get errors because it say error. If you got an error, I'd recommend, since it's so young into building the LFS system, that you restart from where you began. And I mean, I would reinstall my operating system, I would go back through the version checker, I would do everything previously done up to this point here. You don't really want to push through at this stage and happen 5 hours down the road from now when it could have been avoided here. Okay, errors are common everywhere, and sometimes you can push through them. You have to decide for yourself, rather, if you want to redo 10 hours of build for an error you might have missed 6 hours ago. Or sometimes you may get erroneous errors, and if you can push through those errors and your machine still boots, that's another thing. If you got any errors at this point, I would recommend that you restart the whole process. Okay, make install onto GCC 491 in the next two. Peace out.